Alright, in this video we're going to look at Newton's method. Now what Newton's method is, let's say we have a function, but we can't use a calculator to find, say, a root. And the best thing we can do is to use paper and use Newton's method. Now, say if we have a root here, but you don't know what it is. Well, what we can do is use numbers that are close to this value to plug into a function and get tangent lines that come close and close and close until you get close enough to the actual root without using a calculator. Now let's look at the formula used in this method. We have xi plus 1 equals xi minus f of x, f prime x. Now I'm going to explain to you what each part of this formula means. First we have xi, which is initial guess. The xi is the guess that you're going to start with in the problem. And f of x and f prime of x is going to be the function, both a regular function and the function taking its derivative at the bottom. So let's look at a problem. Say we have a problem such as this. F of x equals x squared minus 5 using the initial guess of 2. So what we're going to use in this formula here and in this problem are two main things. It's the function itself and this initial guess. If we plug this in right, we'll come up with a second guess, x2. And further there, we can plug in the x2 to get x3. And this will lead closer and closer to the root that we're looking for the function if we graphed it. So let's look at how we can work out this problem. Alright, let's use the function that I just wrote before. F of x equals x squared minus 5 using the initial guess. I apologize. That should be x1 equaling 2. First thing we need to do, of course, I'm going to go ahead and take the derivative of the function. That way it's easier just to plug into the formula. So what we have is 2x being our derivative. And we also have the initial guess, the derivative, and the regular function. So let's go ahead and plug that into the Newton's method formula. We have xi plus 1 equaling, we're going to worry about this later. First, let's do the right hand side. We have xi, our initial guess, which was 2, minus the function up at the top, f of x, which we know is x squared minus 5 over 2x, which is our derivative. We can go ahead and plug in 2 for the x's since that is our initial guess. I'm going to go ahead and write it at the bottom since we have more space. 2 minus 2 squared minus 5 over 2 times 2. And when we solve this and simplify it, we have 2 minus 1/4. I apologize. That's 2 plus 1/4. There's going to be a double negative, so of course that's going to cancel and put it to positive. And when we solve this, we get an answer of 9/4. So that is our x2, our second guess. See, this all plays back into xi plus 1. Our initial guess was 2. We're adding 1 to it. So we're going to use this to get our third guesstimate. Now what we need to do, we know that x2 is 9/4. And the function again was f of x equals x squared minus 5. So we're going to use the second guess and the function, and we have its derivative, of course, we cannot forget that, of 2x. So let's go ahead and plug that in. We have 9/4 minus 9/4 squared minus 5 over 2 times 9/4. And when you simplify this and subtract that with 9/4, you get an answer of 1/32. And that is our third guess. Usually in these Newton's method problems, it'll state to go to at least the third guess. But of course you can go on to the fourth guess, the fifth guess, and so on and so forth. You'll get closer and closer to the root you're looking for. But in this, we're just going to stop at the third guess. And that's Newton's method.